Welcome, and thank you for joining us for this Sakura webinar, A Case for Change. My name is Kirsten Hill, and I am the Event Manager for Biomedica. Please visit the Biomedica website to view the latest information on Biomedica 2020, a virtual festival of medical science, which will be taking place on the 30th of November to the 4th of December. This webinar will be recorded and uploaded to the Biomedica website. If you have any questions, please put these in the chat box and they will be addressed at the end. And now, over to David and John.
Thank you, Kirsten. And first of all, thank you very much for this opportunity to partner with Biomedica to provide this webinar. So good morning, everybody, and welcome to the webinar, A Case for Change, where we will talk about the Tissue-Tek AutoTEC A120. My name is David Byrne. I'm the marketing manager for the UK and Ireland. And I'd like to introduce to you John Robinson and Grace Maguire. I'll just flick to the next slide. John, here we have a picture of John and Grace at Biomedica 2018. So John is the regional sales manager for Ireland and Grace is the application specialist for Ireland. So Grace is able to support with technical aspects relating to the instrument. So you can put faces to names here. I'm just going to kick off by showing a brief video, and some of you may have seen this video already, but it's only a short video, but it just gives a better idea for those that haven't seen of what it is we're talking about. So I'll just go to the video now, and I hope you find this interesting. And there will be opportunity at the very end of the webinar, to ask questions, and we can address those then. I beg your pardon, sorry. There's always a technical thing.
The AutoTEC.
Right, sorry about this. That's better.
Building on the success and key principles of smart automation, Sakura Finetek proudly introduces the AutoTEC A120 and Paraform Automated Embedding System, second generation in automated embedding. The Paraform sectionable cassette system has a variety of inserts, ensuring locked orientation from grossing to microtomy, suitable for all routine tissue types. The complete lineup of sectionable cassette systems consists of 3 different kinds of cassettes. The Paraform biopsy cassettes are used with smaller or fragmented tissue samples, like GI and skin. For larger tissue, as breast and colon, the Paraform standard cassette is perfect due to the large inner dimensions. For the smallest biopsies or tissue fragments, the Paraform Biopsy 13 by 13 is an excellent solution, keeping the tissue in place with its sponge. The 5 tissue orientation gels are especially designed for preserving the perfect orientation. The biopsy gel can be used as cover and is fully customizable. The 2-lane gel has 2 1mm lanes for skin, shaves, and thicker core biopsies, and the last 3 gels are pre-punched with 1, 2, and 3mm holes, very suitable for GI biopsies. The Express X120 is capable to process continuously up to 120 cassettes per hour. This is matched by the hourly capacity of the AutoTEC A120. With fully automated embedding of 120 cassettes per hour, you enable a lean environment and optimized workflow within your laboratory. Answering to the increasing demand for standardized and consistent high-quality block production, Sakura Finetek created the second-generation automated embedder, the AutoTEC A120. The robotic arm grabs the cassette and transports it to the barcode reader, which scans the barcode and identifies the cassette type. After identification, the cassette is perfectly cleaned by the advanced air blower, preparing the cassette for embedding. The grabber transfers the cassette to the appropriate base mold. The stager presses the cassette through and dispenses the exact amount of paraffin to create the perfect block. Meanwhile, the robotic arm continues and grabs the next cassette. The whole process is being repeated, automatically embedding all cassettes with consistent, predictable quality. The previous embedded cassettes have already cooled down sufficiently, and these blocks are being placed in the output doors, ready for sectioning. The 4 output doors of the AutoTEC A120 provide continuous unloading of the blocks. As the automated embedder produces the highest quality blocks, there is no need for further cleaning or scraping. The 15-inch touchscreen with intuitive and optimized graphic user interface offers simple operation and monitoring of the embedding process. Replenishing of paraffin is made easy and convenient due to the ergonomic positioned paraffin container. The AutoTEC A120 and Paraform automated embedding system offers you optimized orientation while eliminating tissue loss. The second-generation automated embedder leads to a continuous workflow and enhances the user convenience.
Right, thank you everybody for watching. I hope we enjoyed that. So now we'll move back to the presentation, and I just want to kick off with obviously something very important, which is really the single reason why we're all here. And I've had a look at the data from the National Cancer Registry of Ireland, and we're seeing this as a very typical picture across most countries. But the alarming and obviously the take home here is that we have a projection here on incidence between 2015 and 2045, and by 2045 numbers are expected to increase to around 43,000, which is in effect a doubling almost for both men and women. So this represents, as we know, rising number of cases, increasing workload, but also, as we know, there's a greater complexity of cases as well, with more slides, per case. So there is a need here to start to think about future proofing, and what can we do to handle this situation for the future and now in terms of doing the best for the patient. This slide is, I think this is quite a key slide, but it just summarises those generic challenges that we see both in the UK, in Ireland, but also across the rest of Europe. So the picture's very common here, but some of the most common challenges in histopathology are obviously availability of staff. And a lot of labs do have a staff shortage. And for example, the Royal College of Pathologists reported that in the UK, only 3% of labs have sufficient numbers of staff. So things can really only get more difficult as numbers increase. The other thing to say about staff as well is within the industry, a lot of staff are aged over 55. And while there's nothing wrong with that, it means there's potentially a bit of a retirement crisis coming. We then obviously have costs budget to think about. And that's also where it becomes more important to utilise staff really in the places they're most needed, and also in making the most of the skills that they have. We have an increased need for standardisation, and we see this around digital, particularly that, you need standardisation from block to block. And this also relates to diagnostic accuracy. And then again, so we have rising testing volumes, and an increasing ageing population as well is obviously contributing as well to the cancer numbers. So what I'll do is I would like to hand over to John, and John can tell you a bit more about the A120. Thank you, John.
Thank you, David. Good morning, everybody. Yes, as David said earlier in his introductions, I'm John. I look after the business for Sakura in Ireland, both north and south, and work along with Grace. We have had quite a bit of experience with this instrument over the years now, but I hope you enjoyed the video. What I'm going to do now is maybe look at the system in a little bit more detail, just picking out some key points and also looking at some user experiences. And as Kirsten said, feel free as we go through the presentation, if you have any questions, to put them in the chat, and then at the end we can address them. So yes, the AutoTEC A120, some sales bullet points here about everything that was covered in the video. The ideal embedding process, what would it be for you today if you had to have an ideal embedding process? I can tell you that the A120, great machine as it is, it will not do everything. We will always have some of them exceptional cases coming to mind, mega blocks, mega slides, certain things that the A120 won't do, but we can find probably for upwards and above of 95% that it will cover most cases within the lab. Freeing up of staff. Nobody wants to sit on a manual embedding all day. Also, for ideal embedding, we want to look at safe tissue handling. We want to make sure that the tissue, when it's locked, we can prevent loss and keep the orientation. And of course, the productivity needs to be there. We need to see at least the same as what we get out of our manual embedding, if not more. The ultimate time saver, well, it would be nice, yes. We look at the automated embedding, and we will come to this several times through this presentation. We're going to look at what this means in comparison with manual embedding. From a productivity point of view, and again, this would be measured across many workflow studies across all of Europe. I know we've done very, very many in Ireland as well, north and south. But on average, a technician embeds about 69 cassettes per hour. That's a working average that we have took over many tens and tens of labs. So 250 working days per year would be sort of an average. We're also, as it hinted in the video, we look at the scraping of blocks, and the scraping of blocks in an average lab can be anything up to 34 working days per year, but we're going to look at that in a little more detail. Powerform cassettes. I'm not going to go into too much detail about powerform cassettes, but what I would like to say is the instrument uses powerform cassettes. This is the enabler for the system. The system doesn't use our traditional uni cassettes. It has to use powerform. It's a robotic system moving cassettes about. From you load the system, it retrieves, it reads, it identifies barcodes, identifies the type of cassette, it tampers, fills with paraffin coals, and then returns to the output door for microtomy. So the system is a robot. It's a robot, and it does robotic things, but it's the powerform that's the enabler for the whole process. So because it's the enabler, the automated embedding basically starts in the grossing room. So as you saw in the video and in picture number 1 here, we have a technician who has selected the appropriate powerform insert and colored frame. And whenever the powerforms have been put together, either in a number of biopsies or a large resection case, they are put together in this white magazine that you see in picture number 2. The white magazine can then go to either a conventional overnight processor or, as you saw in the video, the rapid processor, the express processor. Either later that day on the express or next morning on the conventional, we unload the magazines, and as you saw in the video, the technician will load the magazines into the A120, and off the robotics go. They will pick, identify, embed, tamper, cool, and return to the output door for the technician to unload, ready for microtomy. And how does it work? Well, we have a series of icons here showing you the various different areas of the machine. It should have been hopefully self-explanatory in the video, but the main areas for the user, because it is kind of looks a little bit like a black box. We had a nice video there to see what goes on inside, but in real life you don't see that. We have the interface screen number 1 on the diagram here. We have we input our samples through number 4, which is the input door, and we retrieve them from number 7, which are the output doors, and these in turn go straight off to the microtomy stations. All the embedding is done in the area of number 8. What it didn't pick up on the video was we also have in this working area, number 9 is a recovery area, and this is a safeguard for the patient samples, because although the machine is quite simple in how it operates, it has to allow for maybe somebody not manufacturing the power forming frame cassettes in the correct way. For example, if somebody maybe leaves a lid open or somebody bottoms out the cassette before it gets tampered, the instrument doesn't want to take any risks. So we do have a recovery area, and when it's scanning the barcode and trying to check which type of insert, it will do various integrity checks on it, and if it's not happy, it will send it to the recovery area. So it will then alert the user to come and retrieve it from the recovery area. And normally it just needs a cassette reinserted or a lid properly closed. Yeah, we would like to think that it brings benefits to all areas of the laboratory, but what does that mean for you guys? It's clearly obvious for the technician. It's the reduction of manual embedding, freeing up time for other tasks within the lab. I don't know too many people who like to sit hours on the end at a manual embedder, but unfortunately, it's one of them things in our traditional process we have to do. The standardisation of the block quality also very important to the technician, and also the reducing of the repetitive strain injuries, which we know we can get, and we feel that the A120 can address all of these. From a managerial point of view or a commercial point of view, the instrument is designed to increase, to handle increased workload numbers, so doing more work with the same amount of people. And in a nice continuous workflow, or a workflow that we set up to suit the embedder, we like to think that we can shorten our turnaround times and get rid of any backlogs or bottlenecks which are around the manual embedding process. For the pathologist, they don't tend to get involved with embedding, but of course they are indirectly involved, because some pathologists will still do a lot of work in the grossing room, but they know that they're locking their samples safe and orientating their samples safe, and they should see on their slide at the end what they have put in at the start of the process. Of course, in a nice lean workflow, we can look at shorter delivery times for slides to the pathologist as well. Yeah, so again, this is just looking from a patient safety point of view. We locking the tissue in the paraffin cassettes, which is giving us it's given us that confidence that the orientation is correct, and that the tissue won't be lost, and that there's no need for reworks, which ultimately is at the end of the day better for the patient care, patient safety. The A120, as we know, is the new generation of histology equipment. So traditionally histology equipment was small, quite manual. Didn't take up much room in the laboratory, but now we're moving to a new generation of histology equipment, more like our biochemistries and our microbiologies, where we have these automated systems, and in turn and in line with that, it comes with its own line of consumables. And because of that, we as a company have to look at new ways of delivering histology equipment. So as a company now, we are looking at leasing solutions and advanced service agreements, advanced user training, lots of things that are a little bit more complex than what we would have done with the traditional histology systems. But in a way, that's nice, because it's also helping us move along in the way that the other disciplines are, especially from quality point of views and audit point of views and standardization point of views. We can now see histology becoming a more up to the minute discipline, like our peer disciplines. Important steps for successful implementation. By no means does Sakura sell this as a plug-and-play instrument. Some of you may know or may have been involved in some of our workflow studies. I know we've done many workflow studies across Ireland, north and south, where we come in and we look at your lab and we speak to the staff. We see how people are doing things, and we try to work out the optimum flow for the laboratory based on the staff numbers, based on the workload size, and based on the layout of the lab. And this is no different with this instrument. So Sakura supply this instrument with a full implementation process and a full implementation team. So we have implementation specialists who will come into the lab and help you get the most out of your workflow. But also it's a hand-holding exercise. We don't put this machine in and expect you to just do it all by yourself and learn it. We will hold hands through the change management process. We will work with the lab managers and with the staff to embrace that change. It's never easy. Nobody handles change well. We know that in life in general, but this really is a big change to the lab, and we appreciate that. And we make sure that this instrument doesn't just come with a new technology, but also there's full backup there from applications and implementation specialists to really get the most out of this for you, and really stay with you until you're comfortable for the handover. Again, we would also do inspiring and interactive sessions on Paraform. So this would usually happen before an instrument was ever installed, so when the instrument comes, it's quite easily implemented into the lab. People can really see then what they're getting from it if they're already familiar with the Paraform. We've some graphs here just looking at growth in the lab, which David mentioned, and preparing for growth. We all know there's no such thing as an average lab, but if we did try and take an average lab of maybe being 500 blocks per day, which is becoming more and more common with the mergers and things that are going on in our industry. If we looked at a 500 block per day and a 5% growth per year, and then 52 seconds per manually embedded block, and we're working on a 260 day per year calendar, with an average working hour of 7.5 hours per day. We can see here just a small graph showing us from year 1 through to year 5, the increase in manual embedding hours per week. So we can see that in year 5, we would have added an extra 7.5 hours to our working week. And again, looking at this, how many, with the same growth level, how many free days could an A120 give you on that estimated growth? So we're basically saying here that we could free up to over 30 hours per week approximately on the same model. Of course, that's based on a 90% utilization of your workload and a 5% growth. So, as I say, we've had this system in the market from around 2007, 2008, which would have been the first generation automated embedder. I know some people are familiar with it. We did have it for a short time in Cork. It was for 7, maybe 8 years in Galway. In 2016, we introduced the second generation. So in that time, we have sold 4 of these systems in Northern Ireland and 1 into Dublin. They're all, the most newest would have been St James's in Dublin, so they've been using it now for over a year, maybe close to a year and a half. But we've just took on a local Irish level some feedback from Belfast, who have been using the system for about 2.5 years. They implemented a full managed service contract back around that time, but the automated embedding was one of the real drivers for change in there during their merger. And these are some bullet points from the lab manager there, saying basically they've reduced the staff from 6 biomedical scientists to 1. They currently have 90% of their production going through the A120, which has obviously improved their flow, give them a faster response time. They were able to free up resources, which was huge for them, not having all that manual embedding to do, and they were able to move staff elsewhere to deal with the bottlenecks. And I can tell you from experience that was mainly in the cut-up room and at the microtomy stations. The biomedical staff there are performing a lot of the specimen dissection in all categories anyway, but now that they've adapted Paraform, it's freeing up the consultant pathologists even more, so they can spend more time reporting cases. And standardisation was a huge thing. We had 2 large labs there that came together with different processes, and they had to try and harmonise processes across the 2 labs, but the A120 made the whole manual to automating embedding easy. So it was a great harmonization of processes, better standardization. Everybody produced the same block regardless of who loaded or unloaded the instrument. We've got a quote here from Jerry Clark, who I'm sure a lot of you may know. This was a quote he done in a recent webinar that we done out across the UK and Ireland. And he was saying that by investing in the A120, one of the real advantages was that I could free up resources from manual embedding and move staff elsewhere to solve these bottlenecks. Beforehand, there were 6 people embedding for a total of 9.5 hours. This has now been reduced to 40 minutes. So I gained 8 hours, 50 minutes, which on average equals the sectioning of 175 blocks. Staff also spent 58 minutes melting the wax on the edges of the cassettes so they could fit comfortably into the microtome. This step is not required now with the A120, thus giving a total save time of 9 hours, 48 minutes per day. This is just a small graph. We were looking at some before and afters when we were in with Jerry on that webinar. I think the big thing there in red you can see is that the microtomy backlog was consistently increasing, but after the installation of the A120, he was able to throw that extra 9.5 hours saved from manual embedding totally into the microtomy to ease with the backlog. Of course, he did see there was other things. I mean, there was a significant change in the standardization, which he said was positive, and he did see a decreased waiting time, which helps with their targets in the patient cancer pathways. Another, again, not a hospital I'm familiar with, but another webinar I sat on over the summer is from Gävle Hospital, a large hospital in Sweden. Again, just to show you that I know lots of people think that their laboratory is unique, and it is in a way. Histology is unique to each hospital, but we always see the same. We see the same trends regardless of the country and regardless of the size of the hospital. This was a hospital in Sweden who have said that they reduced the load of manual embedding down to 1 biomedical scientist instead of 4. They currently have 80 to 85% of their production on the A120, which has resulted in improved sample flow. And a quote from this lady on that webinar was, "Our goal was to improve the overall sample flow through the laboratory. In the past, we manually embedded tissue, moving our production in large batches and operating several similar workstations simultaneously, which is very inefficient. During the introduction of A120, we were able to get a continuous flow, move our biomedical sciences into the microtomy area, where their skills were so much better used. Manual embedding is repetitive work for the biomedical sciences, where small repeated movements are performed continuously and risk of developing repetitive motion disorders. Again, a very similar graph to what we saw in Belfast, but I think the big thing to point out is, microtomy, which you all know is a huge area now, with the slide production increasing all the time, not just for H&E and special stains, but the immuno is forever increasing as well in the panels that are being requested. So microtomy is a huge area of concern in many, many labs now. But the same story here, it freed up a lot of biomedical staff to add to the microtomy team to keep the work moving through. Again, Odense is a large hospital, South Denmark. Again, very similar. I'm not going to read it out, but very similar story. For AutoTEC, with 4 to 5 people occupied in embedding stations from the morning until lunch. We now have 1 to 2, embedding for 1 to 2 hours. So we've gained resources to be used elsewhere in the lab. And of course, it's not just microtomy. These people can use their time to look at enhancing maybe their dissection skills, maybe doing some further portfolios for dissection, or spending more time. Immuno quality is a huge thing. So there's so many areas in the lab that when this time gets freed up, there's so many other, because as some people worry, it's not about losing people or losing jobs. There's so many jobs now that need to be done in the lab, and so few people and so little time to do it. Well, look, this is the last one. It's Oslo. It's another smaller lab. And I think the message here, which we wanted to put across, was that even at a 60% utility rate of their overall workload, they could see 5 hours a day of staff time made free. But yeah, as you can see, same story everywhere. This actually was the first site in Europe to go with the old, the old generation AutoTEC, and then they moved to the AutoTEC A120. They produce between 500 and 1,200 blocks a day. So yeah, I suppose they're not really a small lab, but even with the 60% utility, it means they're embedding more than 120,000 blocks automatically each year. So at this point, I tried to walk you through the instrument and see what it would mean to you from a technician point of view on the floor. But I'm going to hand back to David now just to conclude, and then we can maybe take some questions and answers. So David, if that's okay, I'll hand back to you.
Yeah. Okay. Thank you very much, John. So really, just to conclude and round up some of the main points here. But obviously, we've seen, like John said, the same story, regardless of which country, the instrument's in, but it obviously is freeing up a considerable amount of staff time. And also, I think to point out that in the current climate and the way things are at the moment, there doesn't seem to be anything else within histology that can demonstrate this level of impact. And it really does have to be stressed that this is a considerable amount of time. And obviously the big question would be, what would you do with this time freed up in your lab? And it will vary per lab, but we've seen a variety of examples, including clearing backlogs. But I think also training staff and giving them more opportunity for professional development, or to be involved, in dissection, or playing a greater role in, perhaps in the diagnosis as well. And these are really also the things that, these are the reasons why people trained not to really just sit doing sort of factory style, scraping of cassettes all day long. And again, there are risks associated with that. And we worked out that on average, there's about 17 repetitive movements involved in manual embedding. So obviously this is a really real consideration for someone doing this all year round. Standardizing also reduces errors, and it will eliminate virtually the need, for repeat embedding. And as we said, it increases standardization, and you really only have to look visually at a normal manual embedded block and put one alongside a block that's come out of the A120, and that really does, a picture kind of tells 1,000 words, and it really does explain, the difference is incredible. It's also important though as well about establishing a flow in the laboratory, and one of our key concepts here is moving away from small batches, moving away from large batches, going from person to person into smaller batches to establish a continual flow through the laboratory. And this means that staff are better utilised, and the lab obviously can increase its throughput. And I think most importantly here as well, we have seen several labs that have said that they've actually been able to reduce the turnaround time. And some have also been able to fast track certain samples through the lab to provide pathologists, with the results in a shorter time. And then I think finally, what really this is all about is that, it's about embracing change, and it's about starting to work differently. And it's being in a situation where we can make more out of the resources we've got, and really, for going back to the beginning, to tackle those growing cancer numbers and the challenges. So what I'll do is let's just move on. So just briefly, we have lots of information available, and we can follow up with you afterwards. But I've put John's contact details on here, so John can be contacted at any time. And we have a variety of testimonials. We've mentioned a few of these from other countries that we can provide you with. And the other thing we can also do is, using some very top-line data, we can provide you with a sort of generic, semi-generic kind of word dossier that highlights some figures and illustrates some of the main points and arguments for automating embedding. But also we can quantify the time in terms of, hours per week, days per year that you might save. And if this is a conversation you want to have in your lab about what that means or how you might use that time, then this could be a very valuable sort of starting conversation to aid in that conversation. And also we have quite a few YouTube videos. So I will move on. So we come to the question section. So first of all, thank you everybody for listening. And then we'd like to address any questions that we've raised, that have been raised so far.
Good morning, everybody. As I was introduced earlier on by David, my name is Grace Maguire, and I'm the application specialist for Ireland. So I'm just going to answer some application questions that I see put forward so far. So the first question is, if you don't have a Sakura processor, is this a problem? No, it's not a problem. Our magazines are compatible with our competitor tissue processors. What level of maintenance is required? Actually, it's easily maintained instrument. So normally you'd have your daily, weekly and monthly maintenance, but no, there's minimal maintenance required with this instrument. What causes a cassette to be rejected, and would this happen often? So obviously lack of expertise would cause something like this to happen. So basically, if somebody didn't insert their insert correctly into the frame, this would be one reason why a cassette would be rejected. And another would be if a lid on an insert was not closed correctly. So this would also be rejected to the recovery area in the instrument. So basically, a very minimum number of cassettes would ever be rejected. And but they're easily retrieved in the recovery area, and you would be alerted by the system if this was to happen. So the next question I see is, do you still need the interaction with the sample for put-in specimens such as biopsies, or can they be placed in at a point of removal from patient clinic, for example, colonoscopy? And if so, how do you ensure correct orientation? So basically, what we recommend is that the direct transfer is done by the biomedical scientist in the laboratory to ensure that there has been a safe transfer of the specimen. Obviously, if orientation is very important, it is up to the responsibility of the person who's transferring the specimen. And obviously that person would need to know the importance of how to orientate the specimen. As we all know, certain specimen types require, say, different orientation. So if you had a punch biopsy, yes, you'd need to orientate that on its side, and you'd need somebody to know correctly how they are orientating it. I hope that's answered that question. Let me see the next one. Can the cassettes ensure fine needle cores are all on the same plane? Yes, we have sites that use the Paraform and the A120, and they don't have an issue with their cores, that they are all on the same plane. The next question is, none of the reference sites are converted 100% to automated embedding. What cases are still being performed manually? Okay, so this varies from lab to lab. Some labs might put through some very tiny endometrial biopsy specimens to the manual embedder at this stage, or some people might prefer still, they might like to put their cores through the manual embedder rather than putting them through the automatic embedder. It's a preference of the lab, how comfortable and competent they are with their Paraform and their A120. But as mentioned,
just come in there, Grace, as well. We still have a lot of labs using like the mega slides and the super mega, you know, the double deep Paraform blocks, so things like that, the non-conventional type unicassette. I mean, they're still in use in labs, and they will never be put on the A120 because obviously they don't fit the footprint of the robotics. Just to add that, so that's another reason why we wouldn't see 100% going through the A120.
Okay, thank you, John. And the next question we have is, have the reference sites experienced any issues with section of Paraform cassettes? So from what I'm aware, they don't, but if somebody else on the Sakura team if they'd like to know more about those reference sites, if they'd like to join in, they're very welcome. So obviously, Paraform is slightly different than your conventional cassette. So it just obviously takes time, practice for a few days to get used to sectioning a Paraform cassette. We do recommend that you wouldn't trim a Paraform cassette when it's cold. We would prefer if it is at room temperature because you don't want to chunk your block. But other than that, once you've got a skilled microtomist, there shouldn't be an issue.
Do you want me to handle this next question, Grace? On average, how long does the change from manual to automation take to introduce based on experience from reference sites? I can just answer that from what we've done so far in the country, if you want me to take that one.
Thank you, John.
Yeah, so basically we mentioned the implementation process there. Whenever we were installing an A120, we have a small team who'll come in made up of application and implementation, and we sort of plot out a journey or a vision for the lab of where we are today manual and where we want to be with automated. And we set realistic milestones. So we may say, like, within 3 months, we want to get to 50% of the work, or within 6 months, we want to get to 50% of the work. In my experience, and if I can take 3 or 4 local sites, I would say they all went in excess of 80% within probably 4 weeks, if that is to give you an example. And the reason for that being, I think when people get when we do a Paraform workshop and we don't have an instrument there, people kind of can see all the problems with using Paraform and the extra hassle, but they don't see any benefit out of it. But when you actually bring the instrument into the lab and then people see what the extra time initially spent in the cut-up bench is getting them further down the process, there's no reason to stop or limit themselves to them milestones. And generally what I would see is if we set a milestone of 40% or 60%, they're already using the Paraform to say, well, let's move this tissue type on, and let's move that tissue type on. And you really get this wave effect where a lot of the work then starts going on, because when you see the benefits and the quality of the blocks from 1 or 2 or 3 different tissue types, you very quickly decide, well, why not do it with the other tissue types? And eventually you'll get to a stage where you'll decide, okay, we prefer not to put these on, or we prefer to put these on. But as a general rule of thumb, I usually see on the sites that we've done in Ireland anyway, north or south, that you get above and beyond what your milestones are very quickly, because you actually see the benefits very quickly when the instrument is in the lab. I hope that answers your question.
So that appears to be all the questions so far.
I think, Grace, there was another question about the maintenance aspect.
I answered that earlier, David.
You did cover that. Oh, okay, fine. Yeah, yeah. Sorry, my
no problem.
Questions are looking. Yeah, sorry. So we can address further questions anyway. People can address them directly to John or to Grace. So there'll be ample opportunity and to kind of discuss further. And again, we can provide you with a whole range of additional pieces of information and white papers, testimonials, and things that just may be useful for you on a local level.